Hi everybody, this is page 72 of the vectors chapter in the mechanics notes. We're talking in this video about finding a position on a line that connects two vectors. Right, so we'll jump straight into this example. We've got two vectors that are given to us. The vector A is 3i plus 6j and the vector B is 7i minus 9j. Now, I haven't got too much space here, so I'm going to go over to the side. I'm going to use my grid and I'll do it with the scale axes that we've got. Look at this, beautiful. So A is 3i plus 6j, which is 3 across and 6 up. That's the coordinate capital A there. And the vector little a would be a line going from the origin. Oh, so close. That point there we go. That's little a, the vector A. And the vector B is 7i minus 9j, so I need to go 7 units across and then 9 units down from the origin. So let's do that. 1, 2, 3, 4, 5, 6, 7, and then 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the vector B. Okay, so hopefully that seems okay. I'll change the I'll move myself out of the picture a little bit. There we go. Is that better? Oh, still not better. Where can I move? Should we go up here? Hey, top corner. Look at that. Fantastic. Cool. Right, so we've got our two vectors A and B present. Nice. Now what we're going to do first is we're going to find the vector AB, which is, in other words, how can we get from A to B? How far do we need to go horizontally and how far do we need to go vertically? This thing that I've just put in blue, that's the vector AB. Now, you can either do this geometrically, or you can think about it in terms of the formula that we looked at before for displacement vectors, which was B minus A. I'll write this down here. So B would be the vector 7 minus 9. A is the vector 3, 6. And if you take away the individual components, so if I do, for example, I'll do 7 take away 3 is 4, and minus 9 take away 6 is minus 15. So going from A to B, in total, I've moved 4 units to the mirrored, isn't it? Okay, it's going to be that way. So it's 4 units to the right and 15 units down. So that's fine. We can call that 4i minus 15j. Now where we're going to take this is we're going to start finding points on that line. If we have a little look at the notes here, we're trying to find the position of the midpoint of AB. So I'll go back to my diagram. So I'm going to guess the midpoint is roughly here somewhere. Trying to find that point. Let's call it M for midpoint. You might already have an idea of how you're going to get this, so maybe pause the video, see if you can get it using some techniques that you picked up from coordinate geometry, and then we'll talk about some other methods. Okay, let's get the coordinate geometry method out of the way first. So if you think about it in terms of coordinates, this point here is 3, 6. This point down here is 7 minus 9. And the midpoint formula that you picked up right at the start of the year was this. You take the two x values, add them together, divide by 2. You do the same with the y values. Oh, I've written y2 twice. Oh, dear me. There we go. y1. You average them out and see what you get. So the x values are going to be 3 and 7. I'm going to work out as 5, I believe. Do the same with the y values. 10 over 2 is 5. 6 take away 9 is 3. So I'm going to get minus 3 over 2. There we go. So maybe you managed to get that. Well done if you did. We can piggy bank the idea from coordinate geometry if we want to. The other thing that we can do, we can use a vector method. And I believe it's hinted at it here. There we go. So what it says in terms of text is what we could do in terms of vectors is we could, first of all, we could go onto the vector A, and then we'll go halfway along the vector AB. And they've given us a formula, which is A plus half B minus A. I'll break that down a bit more for you now. So if I want to get to this point M, the midpoint, I could start at the origin. I could go along this vector A, and then I could go halfway along this vector here, and I could stop at the midpoint. That's the idea. And in terms of the formulas, I'm going to say I'll do the vector A first, and then I'll go halfway along the vector AB. And since the formula for AB, remember it's a displacement vector, I can change it into B minus A. And yeah, I can work this out. Purely in terms of the algebra, we've got this. Let's, where shall I put this? I'm running out of space. Let's get rid of the midpoint calculations. See you later, midpoint. Okay, so the vector A was 3, 6. The vector AB was, what do we have it as? It was 4 minus 15. If I run this again, 3, 6, half of 4 is 2. Half of minus 15 is minus 7.5. And I'm going to need to get rid of more previous calculations here. So let's get this down here. 3 plus 2 is 5. 6 plus minus 7.5 is minus 1.5. So we've got the same thing either way. Right? That was with the vector AB. What we could also do is we could individually plug in B and A here. So I could even treat this like algebra. I could say I'm going to expand this bracket, and I'm going to work this out. So I could have 3, 6, 7 minus 9. That was the vector for B. And this should work out the same as well. Let's do this as well, just to clarify that it works exactly the same. Half of 7 is 3.5. That's minus 4.5. There we go. And half of 3 is 1.5. Half of 6 is 3. Okay, cool. So 3 plus 3.5 is 6.5. Take away 1.5 is 5. 6 take away 4.5 is 1.5. Take away 3 is minus 1.5. So yeah, we've got exactly the same thing a bunch of different ways. Wonderful.